Welcome to CBS Easy.
You know that one chapter that can practically guarantee you marks in your CBSE board exams? Well, you found it. Today, we're diving into Applications of Trigonometry, specifically heights and distances. Let's break down exactly how you can master this.
So let's just think about this for a second. Have you ever looked up at a huge building or a super tall chimney and just wondered, how in the world do they know how high that is? I mean, you can't just take out a giant ruler, right? Well, the answer, the secret that surveyors, architects, and engineers use every single day is trigonometry. And that is exactly what we are going to unpack today.
All right, here's our game plan. We'll start with why this even matters in the real world. Then we'll lock down the core concepts you absolutely have to know. After that, I'm going to give you a foolproof four-step method to solve pretty much any problem they throw at you. We'll even walk through a classic exam question together. And finally, I'll leave you with a quick checklist for exam day. Sound good? Let's jump in.
Okay, first things first. Let's get the fundamentals right. Before we can solve any problems, we gotta speak the language of trigonometry. Think of these next few ideas as your essential building blocks. Once you have these down cold, honestly, you're already halfway to the solution.
Everything, and I mean everything, starts with this one idea, the line of sight. And you know what? It's pretty much exactly what it sounds like. Just imagine you're looking at the very top of a building. That imaginary straight line from your eye, all the way to that point you're looking at, that's your line of sight. It's a simple concept, but it's the foundation for everything else.
So what happens when that object is above you? Well, you have to look up, right? You tilt your head. The angle that gets formed between your normal, straight-ahead view, the horizontal, and your new upward line of sight, that's what we call the angle of elevation. Simply put, you are elevating your gaze.
And this diagram here shows it perfectly. See that? You've got the observer looking straight out along the horizontal line, and then you have the line of sight going up to the object. That angle right in between them is the angle of elevation. This is the exact mental picture you want in your head every single time.
Okay, but what if the object is below you? Let's say you're standing on a cliff, looking down at a boat in the water. You have to lower your head, right? Well, the angle between that straight-ahead horizontal line and your line of sight down to the boat is called the angle of depression. Think about it. Your gaze is going down. It's being depressed.
Now pay really close attention to this image, because this is a huge exam alert. Notice how the angle of depression is technically outside the triangle we're going to work with. This is a super common trap. So to solve the problem, you'll have to use your geometry skills and remember that because of alternate interior angles, it's actually equal to the angle inside the triangle.
So let's nail this down once and for all. Do not mix these two up. Angle of elevation, you are looking up from the horizontal. Angle of depression, you are looking down from the horizontal. The key takeaway, both are always measured from that imaginary straight-ahead horizontal line. Got it? Perfect.
All right, now for the part you've been waiting for. How do we actually use these ideas to get full marks on the exam? Well, I'm about to show you a four-step blueprint. This is your foolproof method for basically any heights and distances problem you'll ever see. I want you to burn this slide into your memory. Seriously. Step 1. Read the question carefully, then draw a neat labeled diagram. This step is absolutely non-negotiable. Step 2. List out everything they gave you and what you need to find. Get it all organized. Step 3. Pick the right tool for the job, sine, cosine, or tangent. And finally, Step 4. Plug in the numbers and solve. That's it. That's your checklist every single time.
You know, theory is great, but nothing builds confidence like actually doing it. So let's put our four-step blueprint to the test. We're going to tackle a classic, exam-style question together and see just how powerful this method is in action.
Okay, here's our mission. We've got an observer who's 1.5 meters tall. They're standing 28.5 meters away from a big chimney. Now, from their eye level, the angle of elevation to the very top of that chimney is 45 degrees. Our job, find the total height of the chimney.
First things first, step 1. We draw the diagram, just like you see here. AB is the whole chimney, and CD is our observer. But the really crucial part, it's that right-angled triangle, ADE, that's formed from the observer's eye level. That's the triangle we're going to use for all our calculations.
Now for step 2, let's get organized. We write down what we know. The observer's height, CD, is 1.5 meters. The distance from the observer to the chimney, DE, is 28.5 meters. And the angle of elevation is 45 degrees. What do we need to find? The total chimney height, AB. See, when you lay it all out like this, the path forward becomes so much clearer.
Step 3 is all about strategy, picking the right trig ratio. So, look at our triangle ADE. We need to find the side opposite our angle, which is AE, and we already know the side adjacent to our angle, DE. So, which ratio connects opposite and adjacent? Come on, you know this. SOHCAHTOA. That's right, it's tangent. So we're going to use tan theta.
And now we're at step 4. We just have to plug in the numbers and solve. We set up our equation. Tan of 45 degrees equals AE divided by DE. Now here's the best part. Tan of 45 is just 1. It makes the math so easy. So our equation is just 1 equals AE divided by 28.5. A little multiplication, and boom, we get AE equals 28.5 meters. Simple, right?
But wait, hold on, we are not done yet, and this right here is a classic exam trap where so many students lose easy marks. Remember, 28.5 meters is just the height AE. That's the part of the chimney above the observer's eyes. To get the total height AB, you absolutely have to add back the observer's own height, which is 1.5 meters. Do not forget this final step.
And that gives us our final answer. The total height of the chimney is 30 meters. See how that 4-step method just walked us through the problem, step by step, making sure we didn't fall into any common traps? It just works.
Awesome. We've covered the concepts, we've solved the problem. So before we wrap this up, let's boil it all down into a final checklist. Think of this as your mental warm-up right before you walk into that exam hall.
Okay, remember these 5 things. 1. Always, and I mean always, draw a neat diagram first. 2. Pinpoint the right-angled triangle you're going to work with. 3. Choose the correct trig ratio. Just think SOHCAHTOA. 4, and this is the big one, don't forget to add the observer's height if they give it to you. And 5, just take a breath and double-check your math. Follow these, and you are going to be in fantastic shape.
So there you have it. You've now got the blueprint not just to pass an exam, but to actually measure the world around you. These are the same tools that people use to build our cities and explore the universe. So my final question to you is this. Now that you have the blueprint to measure the world, what will you measure first?
Thank you for watching with us. See you next time.